So let's take a look at how Microsoft implements its data centers to support its cloud strategy. When we think about what Microsoft does and what it focuses on, the first one is obviously reliability. If you're going to take all your customers and all their data and all their services and load that onto your data centers, you better make sure those data centers are fault tolerant, highly available, and reliable. And a core tenet of the investment and the design of Azure is around reliability, both internally and also giving you the option to distribute things like VM workloads, applications, and data across many, many different data centers in many countries or regions to make sure that in addition to what Microsoft is doing, you can choose how to distribute and back up your data for the maximum reliability. Security and compliance, ensuring that it's compliant with not only local and federal government regulations, but to give you the option to enforce corporate policies around data. And then finally, environmental sustainability. Data centers obviously require a lot of power, and making sure that we focus on green data centers and data centers that minimize the environmental footprint is a core tenet of how these data centers are designed. Now, there's a lot of information that you can go online on, anywhere from YouTube to Microsoft.com to Azure.com and see videos and documentation on how things like the data center design is done. It's really quite revolutionary, the way that they've designed the pod systems, the way the infrastructure is done, and some of the statistics are actually pretty astounding. So for example, to give you some idea, about 1.4 million databases on Azure, and this data, by the way, I can guarantee you is old because you're watching this at least a day after I recorded it, so this is now old data. Millions of users in Active Directory, 1.5 trillion messages per month in Azure Internet of Things, 777 trillion storage transactions per day. It's been said that the fiber optic in North America alone can circle the globe, I think, about 6 times, and that there's enough cable to go to the moon and back. 100% of servers and electronic equipment recycled after decommissioning. Again, that kind of goes back to that point on environmental sustainability. We think about some of the other design points. There's a global distribution model. Microsoft's managed it, and it's a modular architecture. All the data centers are made up of individual pods that are brought in as a unit. So there's this unit of compute power that can simply be built, manufactured, and plugged in, and then that adds a certain amount of capability to an Azure data center. Everything runs both Windows Server, which is the same Windows Server that you run in your data center. I was going to say at home, but in your data center, wherever your data center happens to be. When we think about locations, I'm not going to use the slide because I'm going to jump in and just kind of take a look. This is the Azure dashboard, so this is going to be the most current information all the time. Every green checkbox represents an Azure data center location, and there are more data center locations planned all the time. So you can see there's a pretty large cluster around North America, there's a couple of data centers in Europe, and there's a pretty large segment of data centers all around the Asia Pacific Rim, both in Japan, down in Singapore and Australia, and as well a couple in India. So wherever the world's computing power is needed, there's Azure data centers that are definitely close by. When we look at the services that are available in these data centers, the categories go across the top. So when you think about what can we actually do inside all these data centers, it's worth noting, by the way, that not all services are available in all data centers. For example, some data centers don't support the latest generation virtual machine, the very, very large virtual machines, because the hardware that's installed in the data centers may be a couple of years old, so it supports some of the smaller generation virtual machines. But under the compute category, we have things like cloud services, service fabric, virtual machine scale sets, containers. Under data and storage, we have SQL databases. We have StoreSimple, which is a file storage mechanism for uploading files from your local network into Azure managed storage. Under analytics, we have machine learning and something called Data Lake for massive quantities of data. For Internet of Things, this is things like your internet-connected fridge. There's what are called notification hubs that facilitate communication, so your fridge has the ability to report when you need more milk. Under networking, we have things like DNS. You can manage DNS servers in Azure, and then you can implement load balancers and traffic managers. We have media distribution. For hybrid, we have something called Azure Site Recovery that allows you to have virtual machines and infrastructure in your data center, but if your data center goes offline, automatically fail to an Azure instance of your virtual machines. So it keeps it in sync, keeps it up to date. If you go offline, it fails over directly into Azure. And then finally, for identity, as we move to the world of bring your own device to work, to where the device that you have is when you pick up in your local electronics store, it's not something that's issued and managed by your company. It's not something that's subject to, for example, group policy. How do you manage user identity across this world of online applications, multiple companies, and then devices that you don't maintain or manage? Azure Active Directory and Azure Identity allow you to do that. And we'll see some examples of this in other courses on how we set up things like Azure Active Directory and how we federate with external applications. For developers, we have Azure Visual Studio Team Services. In the past, developers would collaborate, but they required what was essentially connectivity on the same LAN. So you'd VPN into work, upload your code, check out your code. With Azure Team Services and Visual Studio Team Services on Azure, that can now be centralized. So as long as you have an internet connection, you can connect to and collaborate with other developers. There's also Azure Dev Test Labs that allow you to automate the deployment of full environments. For example, I have an application that requires 10 servers to fully test. Azure Dev Test Labs gives you the ability to do a template and deploy a test lab to run it and test on your application. And then finally, for management, things like automation. So we can do scripting, schedulers, log analytics to analyze event logs. You can have servers upload their event logs to Azure. Azure Log Analytics will scan those event logs and bring to your attention things that look like they should be checked out. Errors that maybe need some additional attention. Now, we mentioned that not everything is available everywhere. Again, this is, by all means not something that I would expect you to read. However, it gives you a sense that depending on the data center, depending on the location, the services may vary. Now, there's a website you can go to, azure.microsoft.com, regions, that will let you break down in incredible detail exactly what's available in each region. So as you plan your implementation, as you figure out what is it you need, you can visit that website and see where it's available to determine if it's available close to you or if maybe you've got to go somewhere else. The good thing that you can if you look at this in any amount of depth, in every major geographic region of the world, you can get everything. It may be not, East, it may be available in East US, but not East US 2, for example, but it's going to be available in North America. So you're going to be generally close to whatever component of Azure it is that you want to use. So that gives you a sense of, what is Azure's implementation of cloud and just kind of the scale. Obviously there's a lot there. We're focused in this course on the role of IT professionals and how we administer and manage Azure. But as you begin to think about it, you can see how, for developers, there's a component for Azure. For administrators, there's components for Azure. For business users and data scientists, there's components in Azure. So it's a very comprehensive, very large platform.